This video is about machine key and keyways and how you could take an approach to machine the keyway seat or groove, and also putting the correct tolerances so it's easiest for a common 3-axis CNC machine to make the keyway for the machine key. And the first picture I have is a normal shaft, machine key and keyway, a hub, and then on the hub we have a keyway 2 in this example, and then the grub screw or set screw, threaded hole. And the first option we can to make the keyway is to take an NC drill and drill 1 hole or 2 holes, and do the same with the carbide drill, and then plunge almost to the finished depth with an end mill, and then rough 1 time and then finish. Because this kind of way you would have the same depth on the tool all the time, means if you use it for another groove, it's gonna wear out at the same depth every time, so you can always count on it. And the next option is taking a zigzag roughing, where you zigzag all the way down to the roughing depth, and then you take and finish end mill 2 or 4 flute, and then you finish it with 2 or 1 passes, compared to how you set up your diameter and setup of your machine. And here I drew the parts of what could be example. The machine key has different ways and tolerances when you make them, how they should be seated. And if we go into technical data, we would see if you put on an H9, small H9, it's described as fitting so as to permit movement by hand with the lubricant applied, high quality positioning, special high precision sliding part, unimportant stationary part. Now I've made some examples in Inventor on how to put dimensions on the keyway and the shaft, and the first one I made here is what I have seen the most companies do, and this is also what's easiest, as I've heard many machinists tell me to look at. And then there are other examples I have seen which is also working, but they are more difficult to look at and it's not as neatly and nice. Just take an example of this one. It says the width is 8, the total length is 26, and the depth is 7, and the keyway starts at 11 from the end of the shaft. This one works fine, but it's very messy with all the text and XX. It is unnecessary stuff, and it's not as clear instructions to the machinist when he has to work on it. This one though is very neatly made, and there's clear tolerances on what is allowed and not allowed. And if you see at the which write 8 and H9 fitting, and this one has nothing to it, because this one, the only way to understand the fitting of the key is that either there's a standard tolerances description on the machine part drawing, or that the production itself already know who is the machinist, who is engineer who is drawing, and they would definitely know what they want to put in that groove. It's a key, of course, and so they would fit it themselves, the machinist, so it fits. But this one you can give it to anybody and they would understand what is going on, because you have a tight tolerance of the width of the keyway, and then you have also describing at depth what is allowed, and you have the section which makes it very easy to see that it's a keyway in a shaft. And the tolerances are starting from the end of the shaft to the middle, not the start of the keyway, but to the middle, the center of the radius on both of them. Because this one, when you do it like this, 15 from the end, you can minus the width. So if you make the keyway 8 millimeters wide, you can take the half of it, 4, so 4 minus 15 minus 4, which is 11, and you can take a slide caliber and put it at the end of the shaft to the keyway, and you quickly know whether you are completely wrong or it's somewhat correct. And you can of course measure after with micrometer or a probe. Thank you for listening to my horrible voice. This is just what I wanted to show people in the machine industry, that this kind of drawing is very neatly and very nice. And look, if I'm a little bit more clever, I know how to move this. Yes. And thank you for watching.